So this is example 2. I'm going to show the solutions to the 3 exponential equations that have been posted. The first example is stating that 5 to the power of some number x is equal to 125. Now, the easiest way to solve for this is to simply use trial and error. What number could x be so that 5 to the power of that number gives you 125? Well, if you want to start, we could test values that we already know. For example, 5 to the power of 2. We know 5 to the power of 2 is 25, so that's definitely not the right answer. On your calculator, try different values for x until you find the one that equals 125. And we don't have to go very far because we'll see that 5 to the power of 3 is in fact 125. So the solution to this exponential equation is x equals 3. Next week we're going to see how we can solve for x directly using logarithms. But for now, something as simple as trial and error is perfectly acceptable. If we move on to B, we have something a bit more complicated, where we say 2 times 5 to the power of x is equal to 1250 or 1250. The first thing we need to do is isolate what I'm going to underline here as the exponential part of the equation. So we want to get this highlighted part here alone. Well, how do we do that? We need to divide both sides by the coefficient, which you see is 2. So if we divide the left side by 2, we can divide the right side by 2. That gets rid of the 2 on the left, so we're left with 5 to the power of x. We divide 1250 by 2, we end up with 625. Okay. Now this just looks like example A. 5 to the power of what is 625? Well, we know it has to be greater than 3. Let's try 5 to the power of 4. And we do that, we see that we get the answer 625. So again, we're doing this using simple trial and error, and that's okay. So the solution is x equals 4. Let's look at example C. Something a bit more complicated here. 2 to the power of x minus 3 equals 4 to the power of 5x plus 1. Okay, how do we start this? I want you to first highlight the fact that the bases are not the same. Here we have a base of 2. Here we have a base of 4. I want you to ask yourself the question, how can you rewrite one of the bases so that it looks like the other base? Well, in this example, we can express 4 as 2 to the power of 2, which is great for us because now what we can do is rewrite this exponential equation as 2 to the power of x minus 3 equals, instead of writing 4, I'm going to write 2 to the power of 2. And I'm going to keep that exponent the same. So again, I've literally just rewritten the 4 with a base of 2. So the next thing you want to do is simplify the right side of the equation by multiplying the 2 to the 5x and to the 1. It's like you're using the distributive property. So I'll just make a note of that here. Multiply the 2 to 5x plus 1. Well, what does that give us now? The left side is still the same. 2 to the power of x minus 3 is going to equal 2 to the power of 10x plus 2. Okay, well that's great. We still have to solve for x, but the beauty of this is that our bases are now the same. So because of that fact, 2 and 2, what we can do is, I'm just going to draw an arrow, is set the exponents equal to each other. Then you can solve for x. So let's do this. I'll write it out here first, and then I'll solve on the next slide. You're going to state x minus 3 equals 10x plus 2. Now, you shouldn't need a lot of help to solve this. This is a simple 2 or 3 step equation. Collect the variables on one side, bring the constants to the other, and we can solve for x. So I'm going to do that on the next slide. We have x minus 3 equals 10x plus 2. I'm going to move the 10x over, move the negative 3. X minus 10x equals 2 plus 3. And we have 1 minus 10. We have negative 9x equals 5. Divide both sides by negative 9. Those cancel. X is equal to negative 5 over 9. So the solution is x equals negative 5 over 9. You're going to use these strategies to complete a practice page at the end of the lesson. For now, return to the page and look at example number 3 and the solution provided for that question. When you're finished, open the 4.3 practice page, and you may want to revisit this video to check for some help when solving those equations.